Hello and welcome back to AGT STEM. Today we're going to be watching a video about scandium. So, without further ado, let's hop to it.
2 or 3 days ago, I got a letter from one of our fans. And it's different from any other letter that we've ever had. Because this fan, Jan, has attached to it a sample of an element. And what's more, it was an element that I'd never seen.
What did he know?
It's scandium. It's only a small piece.
I was going to say, what has he never seen? Because I bet he's seen a lot of things. But we already know, because the video is about scandium.
But according to my colleague Steve, it's a very expensive element. So this might be quite valuable. And scandium is a really interesting element. Much more interesting than I realized when I first talked about it on a video. Scandium is an element which chemists usually ignore. I've never used scandium in any of my research. It was one of the elements that Mendeleev predicted ought to exist when he first devised the periodic table. When he made it, there were lots of elements that were not known, but what he did was to predict that there were holes in various places where he felt there ought to be an element. And because these elements obviously didn't have names, he called them boron or aluminium or silicon, meaning underneath those elements. And that's
pretty cool how he predicted elements that no one even really knew or thought to existed yet.
The triumph for the periodic table was that people actually discovered these elements. And the first one that was discovered was the element gallium, aluminium, and the second one was boron, which is scandium. Now you might think it's a bit surprising, because if you look at a modern periodic table, scandium and boron are really quite a long way apart. But in the original way that Mendeleev started the periodic table, when he wrote it down first, scandium and boron came very close together, because both of them have 3 electrons in their outer shell, which makes their chemistry quite similar. Of course, Mendeleev didn't know about electrons, but he guessed from looking at titanium, which has 4 electrons, and calcium, which has 2, that he thought there was something missing. And what's also interesting about these 3 elements that he predicted, that they all ended up with names of countries. There was gallium that was named after France, from the Latin word from France. Scandium that was named after, well, perhaps not a country, but a region, Scandinavia. And then germanium that was named after Germany. The first...
I'm sure that's a coincidence, but it's pretty funny how every single one that he predicted got named after a country or region.
Time that an element was discovered, when gallium was discovered, people said, well, it was just luck. But when scandium was discovered, they really began to take Mendeleev pretty seriously. And by the time germanium was discovered, they really all decided that Mendeleev was right. Scandium, because it's quite an uncommon element, is one where people don't know much about the chemistry. I've never really done any research in this area, but like many elements, suddenly there comes a time where they become really quite popular and topical. And now is the time for scandium. And the reason is that scandium is a very light metal. Its density is slightly less than 4. That's 4 grams per cubic centimetre. And that's very much lighter than most metals. Copper is nearly 10, and lead and gold are close to 20. So this is really very light. So why shouldn't metals be important if they're light? And the reason is that sometimes you want to use a metal, but you don't want the object that you make to be very heavy. And so, for example, titanium...
It makes sense. Like, if you needed to make like a metal part for something that needs to be carried or moved a lot, maybe like pieces of a car and like the tires or whatever, needs to be light. So makes sense. So I guess scandium would be a good one. But as he said earlier, it's pretty expensive. So I don't really know how that would work out if you're trying to make something light, but you don't want it to be super expensive. You could probably just use titanium, but I also think that that's kind of expensive too. I don't really know.
Uranium, which is very light, is used for making everything from golf clubs to jet fighter planes, where you want it to be really light, either so you can swing it fast or fly fast. For scandium, the reason's rather different. People are now thinking about using hydrogen to power cars, to use hydrogen gas as the fuel to power cars. But what they want to do is to store the hydrogen in the equivalent of the petrol tank. You can't just pressurize the hydrogen as in a gas cylinder, because the container would be so heavy that your car would be like a military tank. It would be so heavy. So what they want to try and do is to produce a chemical compound which is a bit like a sponge that will absorb the hydrogen, and then, for example, if you warm it gently, the hydrogen will come out. And it is here that you want the metal to be light, because you want this material that you're using to store hydrogen not to weigh very much, because you've got to cart it around in your car all the time. And scandium compounds are now looking really quite promising for storage of hydrogen. And the idea is that rather like a molecular model kit where you have balls joined with sticks, you can use organic compounds, those of carbon and hydrogen, with a little oxygen, like sticks, to join together scandium atoms.
That's pretty cool. So you take the hydrogen and I think he said oxygen, and you put them and they hold together the scandium, and I guess it makes it kind of stronger.
And produce a structure which has a lot of holes in it. And then the hydrogen can go into those holes and be stored without needing an enormous pressure.
Sounds like an incredibly complicated way to make a fuel tank.
It is quite complicated, but on the other hand, if it works, you don't need to understand the chemistry. You just add the hydrogen to your tank and away you go.
How can you have got to your ripe old age as a chemist and never have seen scandium?
Well, chemists very often use compounds, salts of metals, but it's not so often that you use the metal itself. And salts, because they don't have to be purified and so on quite as much as the metals, are easier to get. They're not as expensive. And so there are lots of the elements I haven't seen, but I'm really quite pleased with this sample of scandium. So when I'm finished, I'm going to frame it and hang it on my wall. So we have one of our students, works with one of my colleagues, Martin Schroeder, and this student has done his whole project, 3-year project, on the chemistry of scandium. So when I got this letter, I asked him, have you ever seen scandium? And he hadn't. He'd never seen the metal, so he was really quite excited to see John's letter.
Sounds like everyone over there is super excited about the scandium they got. Well, thank you so much for watching. We'll see you next time. Stay smart. Bye!